Okay, chapter 8.2 on solving equations with the different forms such as ax plus b equals c and x over a plus b equals c. Now remember, these two templates are really a coefficient and a variable and a constant equals a amount. And this is a fractional coefficient, like for example x over 2. That's the same thing as a half of x, or decimal coefficient if you want to think of it as that, plus a constant equals an amount. All right, so here we have in example 1, it says 2x plus 1/10 equals 3/5. Now some people ask me, Mr. McDonald, can we just change them to decimals and work it out? Yes, of course you can if you weren't doing it for the purpose of demonstrating your proficiency with fractions. So for these particular types of questions, if they're written with fractions, you must solve them as fractions. If you'd like to go back and check them with decimals after to make sure you have the right answer, that's okay as well. So if you look at the solution, there's actually two ways to do it. You have solution the first way, which is of course what we're going to talk about right now, which is subtracting the constant from both sides. And then we have the second method, which is B, which is multiplying both sides by a common multiple of the denominators. So we're going to start first by looking at what it did. Well, here it said, okay, just as if it was 2x plus 1 equals 3, the first thing that we've always learned is to get rid of our constant first by applying opposite operation. Well, that doesn't change just because it's a fraction. So we must subtract 1/10 from both sides. Here I get to apply the opposite operation, so those two created a zero pair. They're gone. I'm now left with 2x equals whatever 3/5 take away 1/10 is. Now for here, what skill do you need to have? Well, you definitely need to be able to subtract fractions. So I know that I need a common denominator, so we use 10. And the reason why we use 10, I'll just refresh your memory, is that it's the first common multiple the two share in common. 10 will work. It's the lowest common multiple, or therefore the lowest common denominator that we can use. We could have used 20, we could have used 50, but we're going to use 10 because we keep our numbers low and the reduction at the end low as well. So here we have 6 over 10 because they're both they're both equivalent fractions, excuse me. 1 over 10 doesn't have to change, so 3/5 take away 1/10 is the same thing as saying 6/10 take away 1/10, which of course is 5/10. Now we also know that 5/10, if I wanted, I could put 5/10 here, or if I wanted to, I could also say, well, hold on, why don't we just reduce this to lowest terms and use that instead of 5/10? Let's use 1/2, because 5/10 is 1/2. So now what I've done, after just subtracting 1/10 from both sides, I've now created an equivalent equation that says 2x equals 1/2. Now I know I divide both sides by 2. And I divide this side by 2. I end up with x equals, and here I have a fraction divided by a whole number. And this actually transports us right back to grade 8 again, when we learn how to divide fractions by whole numbers, or in this case, fractions by fractions. And what I want you to do here is consider that 2 is really 2 over 1. And when you divide fractions, the rule I taught in grade 8 is never divide them. The shortcut rule is change it to multiplication and use the reciprocal of the second fraction. So the second fraction was 2 over 1. The reciprocal is a fancy word for flip. Now I have multiplication of fractions, so I multiply the tops, I multiply the bottoms, I end up with my answer of 1 over 4. Okay, let's just practice one of those questions. So my answer, by the way, is x equals a quarter, and we see it right there. X equals a quarter is correct. So it says go back and substitute and check. I don't like the number line equation or the number line example they have there. It's not a bad one. It's a little bit cumbersome and time consuming. If you wanted to really check it, you would just go back and change it for your x variable and see if it worked out to be equivalent on both sides, right? So you can work out that equation, make sure that both sides equal 3/5, and Bob's your uncle. Let's try the second method, however. So the second method says you may prefer to work with integers than to perform fraction operations. So instead of using, again, fractions, you could change the fractions to integers by multiplying by common multiples of the denominators to both sides. So let's look at, do we give that same question? No, we don't. We have only the second one, I think. We have the second equation. So let's do the second equation two ways. So the first way, let's try it first using the first method, which is getting rid of the constant. So here we have a constant of minus a half. So we're going to add a half to both sides, opposite operation. Over here I'm left with k over 3. Extend the page. So what is negative 1 and 3/4 plus a half? Well, we're going to add these two together, right? That's what we're going to do. We're going to add those two. And it's sometimes easier, in this case not really, but it's sometimes easier to change mixed fractions to improper fractions and deal with it that way. So I'm going to do that. Remember, when we change a mixed fraction, we multiply the denominator by the whole number. So 4 times 1 is negative 4. Or 4 plus 3 is 7. So 7/4 or negative 7/4 is the same value as negative 1 3/4. So this is the same question. I hope you can see that. If you pause and take a look at it and study it and go cross-eyed, you will see that that indeed is the same equation. I'm adding fractions, which means I have to add common denominators. So I'm going to change 1/2 to a equivalent fraction, 2/4. Negative 7/4 stays the same. And remember, I'll go back down here. When you add fractions that have the same denominator, it's sometimes good to show this step here. It's negative 7 plus 2 over 4. That way you see the integer operation. I have 7 negatives and 2 positives. What do I have more? If I have more negatives, how many more? I have 5 more negatives. So my answer is negative 5/4. Now here I could do one of two things. I have now a fraction equaling a fraction. Now the first thing you probably would think to do is multiply both sides by 3. Multiply by 3. I get negative 15 over 4 equals k. Right, that's your answer, which is going to be, as a mixed fraction, negative 2 or 3, excuse me, and 3/4. But here's where it gets interesting. If you go back to when we studied proportional reasoning, you realize that this is actually similar to a proportion, and we could cross multiply. And for this particular one, it's probably not easier to cross multiply. It's probably easier to multiply by 3. But what we could do here is multiply this way and get 4k, and multiply this way and get negative 15, then divide both sides by 4. And I still get the same answer I got before, k equals negative 15 over 4. But I recognize the proportional reasoning that I could actually cross multiply and be able to work it out that way as negative 15 over 4. But the second method, which is where we're getting to, for that first method, if I go back in time and get rid of it all, boop, 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 right to there. What the book says is the second method, what you could do is you can multiply both sides, oh, that's not 6, sorry, by a common multiple of the denominator. So if I look at the denominators of this term, and this term, this is a 3, this is a 2, this is a 4. And if I find a common multiple of those three numbers, 3, 2, and 4, 3, 6, 9, 12, 2, 4, 6, 8, 10, 12, 4, 8, 12. The first multiple they all share is 12. So what that means is, if I think of this as being a balance, and I think of this as being a third of a variable, take away a half, so a negative half, that's negative half equals an absurd amount, which is negative 1 3/4, right? Whatever. I'll just shade this in so it's not included. This is a really awkward one to draw. But if I think about multiplying this side by 12, I would end up having 12 of these, which would actually make 4, 12 of these, and 12 of these. That's essentially what we're doing here. So if we think about algebraic equations, by multiplying this side by 12 and multiplying this side by 12, I'm keeping my equation equivalent. But more importantly, I'm able to create an equivalent equation that has integers instead of fractions. So let's look and see why this happens. Well, a third of k times 12, remember using distributive property here, A third of k times 12 is really 4k. And we could show that by 12 over 1 times k over 3, if you'd like to look at it this way, is 12k over 3, which is 12k divided by 3, which is really 4k, right? So we have 4k is our first term. Then we use distributive property to go to the second half. 12 over 1 times negative 1 over 2, because we're really using the subtraction as a negative, becomes negative 12 over 2, which equals negative 6. So when I multiply a third of k, take away a half by 12, I end up with 4k take away 6. Again, there's no fractions there. And if I increase this side by 12-fold, negative 7 over 4 times 12 over 1. Look at that. Now I could multiply 7 over 4 by 12 over 1. Or like we talked in our last lesson, I could reduce this. 12 over 4 is really 3 over 1, because I could divide both by 4. I end up with negative 21 over 1, or just negative 21. Okay, so here's our new equation. It doesn't have any fractions in it, but it's 12 times bigger, and we can still isolate the variable and figure out what the variable is, and it'll still be the same thing as if we did it the last time, the same way we did it. So if we add 6 to both sides, I have 4k equals, well, 21 negatives and 6 positives. What do I have more of? Negatives. How many more? I have 15 more negatives. Is that right? Should be. And then I divide both sides by 4. And I still have the same answer I had before, negative 15 over 4. This was an easier way to get there, okay? So what I'm going to try to do now, right with you right now, is try to show you know. And what we're going to do is we're going to try two methods. We're going to take the same problem, the first one, 2y plus a half equals 3/4. And we're going to do it on both sides, 2y plus a half equals 3/4. What I would like you to do is this way, I want you to do it the standard method, which is going to be constant first, and work it from there. And this one over here, I want you to multiply both sides by a common factor from the denominator. So look at the denominators and multiply both sides by a common multiple of the denominators. Remember, 2y, that's a hint, is really 2y over 1. So the denominator there is a 1, but you won't really need that, okay? So press pause, try both of them, see how you do, and check your answers in just a second. Okay, welcome back. So you got your answers. That's good. Hopefully the first thing you did here for both sides was subtract a half. You get 2y plus a half, and you subtracted a half to use opposite operation to get rid of the constant. You're left with 2y. And you realize that taking a half away here is the same thing as taking away 2/4. So 3/4 take away 2/4 is, yes, that's right, 1/4. So you ended up with the equation 2y equals 1/4. You then divide it by the coefficient of 2. You divide it by 2, which you realized was 2 over 1. You then change that to multiplication by the reciprocal. And you got y equals 1 times 1 over 4 times 2 equals 1 over 8. And your answer for y was 1 over 8. Okay, 1/8. Now hopefully over here, you looked at it and say, well, what are the denominators? Well, this is a denominator of 1. This is a denominator of 2. This is a denominator of 4. What's the lowest common multiple those three share? Well, some of you probably used 8, which is okay. It is a common multiple, but it's going to make your equation slightly bigger than it needs to be. 4 is probably the best choice because it's the first multiple they share. So remember, I'm multiplying the sides by 4, not one term. So this side is multiplied by 4, and this side is multiplied by 4. I'm going to show it like that. Distributive property kicks in here. 2y times 4 is 8y. Aha, no fraction, even though there wasn't a fraction before. 1/2 times 4. Now, hopefully all of you can do 1/2 times 4 in your head without having to resort to paper, because if you think of it, but what 1/2 times 4 means, it means 4 halves, which is 2. And then equals, remember I could cross reduce here. 4 over 4 is 1 over 1. That leaves me with 3 over 1, or just 3. So I've created this equation that does not have any fractions in it, which is lovely. I subtract 2 from both sides. I get 8y equals 1. Divide both sides by my coefficient, and I get y equals the same answer that I got over here, 1/8. Okay, did that work for you? Hopefully it did. If it didn't, let's try B right now. And if it did work, try B right now. Both ways are going to make you happy, happy, happy. Give it a go. See how it works. Here's your questions. For the same thing, I want you to do both methods. First one is n over 2 take away 3/4 equals 2 3/8. And over here we'll do the same thing. Hope you're copying this down. Don't be lazy. Okay, so here we want to do the standard method of constant first, then coefficient. And over here I want you to multiply by common multiples of the denominator. Okay, have at it, press pause. Welcome back. Okay, so hopefully the first thing you did was you changed this to adding 3/4 to both sides. You cancel that out, you're left with n over 2 equals whatever this is going to be. Now you have a mixed fraction, which stinks, so you have to look at 2 3/8, so that's 16, 17, 18. That's actually 19/8. So I'm going to change that to 19/8. And realize that I'm adding fractions, so I need a common denominator. 19/8 plus 6/8 is 25/8. And I won't change it quite yet to mixed. I'll leave it in improper until I need to change it. And that's what I have here. Multiply both sides by 2. I have isolated my variable, and over here I have 50 over 8, but if I cross reduce, I have 1 over 4. I can't reduce that anymore, so I have 25 over 4, which is the same thing as 6 1/4. Okay, so using the standard method, I got the value of n is 6 1/4. Now over here, I'm going to change this back over here. 2 3/8 I'm going to change to 19/8. I'm just going to keep it like that in there. Sometimes it looks better. It's easier to work with. Usually improper is the easier fraction to work with anyway. So I have a 2, a 4, and an 8. My common multiple is, that's right, 8. So I'm going to multiply both sides by that common multiple to create an equation that is fractionless. 1/2 n times 8. 8 over 1 times n over 2 is 8n over, I can cross reduce here actually. 4 over 1 is 4n over 1, or just 4n, if you think about that. Half an n doubled is a full n, so increased by 8-fold is going to be 4n. 8 times negative 3/4. I'll work that over here. 8 over 1 times negative 3 over 4. Cross reduce, 2 over 1. Negative 6 over 1, or just minus 6. Because 3/4 times 8, or negative 3/4 times 8, is negative 6, or take away 6. Here it's quite easy to see. I can cross reduce here. I'm left with just 19. Add 6 to both sides. I get 4n equals 25. Divide by 4. And Bob's your uncle. Look at that. I ended up back where I was before. N equals 25/4, or 6 1/4. All right, that was a fairly long video, but it was necessary because it's a fairly complex chapter. If you have any more questions, you can come see me personally about it, and we can work. Remember, extra help classes are Tuesdays and Thursdays after school until 4. It wouldn't hurt you to show up.